different topics whatever we are attending. So on that regard, today I will be starting this and we will try to convey few things like what is what is sensors, the definition and understanding, and then operation principle of different sensors, and what kind of sensors we generally use for healthcare applications. And since there are different kind of sensors are working in different principles, I'll be discussing the chemi-resistive sensor, means the resistance of the sensor changes in presence of chemical environment. So you be attentive and hopefully you will be learning something new today. Make it interactive. Whenever you have any queries in mind, don't think that's a silly question to ask me. I'll be happy to interact with you, whatever I know. Fine? So start sensor, and you know all of we have these 5 sensors in our body system. These are the 5 sensory organs, and you know this smell, sight, touch, hearing, taste. So what is the definition of the sensor? While I'm asking you the question, don't try to give me the answer, but you think on it. What is a sensor? And then will this work discreetly? Means if I take out my nose and keep it here on the desk, will it work? Or if I keep out or take out my nose, ears and then keep with you, will it work? So the system is very important whenever we are working on the sensor. And sensor, what is the sensor? What is the transducer and what is the actuator? These are the 3 terms you will be finding mostly: sensor, transducer and actuator. Mostly these are valid for the chemistry, valid for the mechanical, electronics, mechatronics. People are working on different dimensions, and these 3 terms, often it is confusing what is sensor, what is transducer and what is actuator. So today we will be learning what is these things, and you know sensors will work there where there is system. The sensors are accommodated in our body system, that's why they are working. Okay, so then we have this brain, we have transduction system that I will be talking to you little later. So even if you, as I told you, you have ear, nose, but you know these are not only the sensory organ. If you know if you go to the this internal mechanism, you will be finding the different things are here with the sensors. So sensors are always, these are, you can see this is here, only this is the sensor or the receptor part, and these are the transducer, and then there are other actuating part. So always sensor is composed of receptor and the transducer. So what is the receptor, what is the transducer and what is the sensor? First we need to understand. So this very thing, I will be giving you one example to let you know what is sensor, what is transducer and what is actuator. So suppose we have one mosquito bite here in hand. When there is a mosquito bite, the mosquito bite is analyzed, or it is the target, analyzed. When it is biting, so this surface, it is a sensor, and then sensor, that signal is produced here, and then it is coming to our brain. So this part is the sensor, then this is the transduction. Doing this thing, it is the actuation, right? Actuation is involved with the mechanical system. Sensor and the transducer. Sensor is the chemical, transducer is the electronic, this is the mechanical. Sometimes you may not require this actuation. Suppose you are in the agricultural field, you have a moisture sensor and your field is dry. So sensor is giving you this information whether your field is moist or it is dry. So that is sensor. And then whenever it is giving you the signal to the control system, that operation or electric or electronic system, that is called transduction system. And when it asks this system to switch on the pump to deliver or to give you the water in that agricultural field which is dry, then that is the actuation. So I think now the sensor, transducer and then actuation term is clear to you. Now sensor, obviously when it is a sensor, it's a chemical entity, and that chemical interaction with the analyte. The analyte can be physical, the analyte can be chemical. Physical analyte means some what is the temperature, pressure, these are the physical analyte. And then chemical analyte, the environment like gas or like some other liquid, depending on their composition, depending on their toxicity, depending on their nature, we may have different kind of chemical these entities. So a sensor by definition could mean a machine or a module or even a molecule or material that responds to a physical or chemical stimulus and transduces the signal to a control device which gives information on the detection and measurement of the stimulus is called system. No need to remember this definition, but your understanding is very important. So now, if you wish to prepare a sensor, obviously you are targeting a stimuli, that may be physical, that may be chemical, and then you need a receptor, and you need some transduction system there, and then you will be getting the signal. Depending on that signal, what you want, if you wish to give you the instruction for the actuation, then you may give. If not, you may record the signal. Right? So obviously, when we are getting the signal, we need to get the three things of that signal. That is the sensitivity, selectivity, and stability. Sensitivity means how fast you are getting this interaction and how fast you are getting this response from that analyte is called the sensitivity. If it is very less sensitive, it will take longer time, so it is a bad sensor. Selectivity means for selective this analyte, you have a different kind of signal. So suppose you have a smoke detector there, and it cannot identify where from the smoke is coming, whether it is coming from edible oil, vegetable oil, or it is coming from this cigarette smoking. If it cannot discriminate these things, then it is a non-selective smoke detector. So if for a specific purpose you may need some selective. So selectivity and then stability. Stability means if you have a very means interaction, then all the time you need to get this repeated signal. If you do not get the repeated signal, so then you may give a false alarm. You may get a false alarm. Sometimes the intensity is very high, sometimes the intensity is very low. So you will be getting this false alarm. So these are the three things. It is important to know for everyone, for every sensing system. Now I am coming to little bit narrowing down the field. So there are so many these sensor. They are working on the different principle. So there are optical sensor. Once you can find the change in the color. You can find the change in the capacitance, that is capacitive sensor. You can change in the resistance of the signal, that is the semi-resistive sensor. And you can find the electrochemical change, then it is electrochemical sensor. Even you can find the change in the pressure. Whenever you are getting some pressure on the device, you will be getting another signal. So now IPL is going on. One ball is striking to the wicket, and you are getting some light on that. That is also because of some sensor. Okay, so that is called that again the styloelectric or the piezoelectric sensor. So now I'm not sure what is your background, but electrochemical sensor that is associated to that chemistry and electrochemistry is very important for measuring the different presence of different chemicals, and this is the operation principle of one electrochemical sensor. So after discussing this sensor, transducer and actuation, now I am coming to the sensor part. So I am now discussing this electrochemical sensor. So as you can see here in the electrochemical sensor, how we are measuring, basically we are in the electrochemical sensing. We do first one scanning. We have three electrode. One is called this working electrode, another is the reference electrode, and then counter electrode. Okay. So working electrode, what we do, basically in the working electrode there will be the interaction with the analyte and then our material. So we do prepare this working electrode, and then we put voltage to the working electrode with respect to the reference electrode. and then whatever there is current, we are getting in the counter electrode. So this is the 3 electrode system. So this is the first 3 electrode system, whatever we built in that lab first. Then we measure, this is called the cyclic voltammetry, and from cyclic voltammetry, amperometry and other things we are also getting. So these are the some signals we are getting from electrochemical sensor. But this electrochemical sensor, whatever we do in the lab, that always you cannot take it into the field. So in the field you will have to take some kind of other system which is equivalent to that 3 electrode system which is shown here. So that's why nowadays you are getting this kind of strip. Okay, this kind of strip, and here also you will be getting the 3 electrodes. As you can see here, this is the point where you can put your this analyte, and this is CE means the counter electrode, WE means the working electrode, and then this is the reference electrode. So same system, now it is integrated into the miniaturized system, and then you can take it into the field and you can create a signal. You can, if you want to analyze the water, then here it is being analyzed, detect the glucose in the diabetes. Diabetes means we have this blood sugar, so that can be detected using this type of electrochemical sensor. So this is one type of sensor mostly used by different these end users to detect different analytes. So this is electrochemical sensor. This is called chemi-resistive sensor. Chemi-resistive sensor means, as I told, here as you can see, the conductance or the resistance of the this any material that is changed in presence of different chemical environment. And in market you will be finding this kind of sensor. In this sensor, some material, mostly the metal oxides are there. The resistance or conductance change of the sample. Suppose the your in here, suddenly there is a leakage in the CO2 leakage or methane hydrogen leakage, you will be getting a different resistance of conductance. So that will give you the signal. So this is called the chemi-resistive signal, which I will let you know little later again, because I will be discussing more on this topic. You have this piezoelectric sensor. All the time we are measuring how much is the heart rate, how many steps is involved through our smartwatch. What is there in the smartwatch? What is there? And that is there also one kind of piezoelectric sensor. And then piezoelectric sensor means that there is a pressure, pulse, and as you can see here, this is a pulse artery, and you are getting this is whenever you have pulse, there is a wave, and this wave is generating electricity, and from that we are getting the signal. So whenever there is a sensor with us, that smartwatch is also a sensor, and in that sensor one piezoelectric thing is used. Even if you are interested, if you are from this electronic background, you may get this thing. You just write in that Amazon, you'll be getting a piezoelectric sensor, and bring it, and then you do your own study. Even you can prepare your own sensor. Okay, just bring it and then you start this working. And then again, this is a triboelectric sensor. It is called this triboelectric sensor, and it is saying it is triboelectric nano generator. And if you wish to monitor this different pulse rate or this movement of the body system, then you can get the signal. Even when it is connected to the Bluetooth, you can acquire the signal from outside. So that signal, whenever you are working or you are doing exercise, what is the beats per minute, that you can also get from outside. So suppose you wish to monitor the BPM of your father or mother from here, you can do that. You have a Bluetooth device here, and that is connected there with your parents, and then you can monitor this thing. So this is a transduction system. There is a sensor, but transduction system now is connected with this thing, so it can give you the signal. So I am not the expert on that field. Our sir is expert on that field. But the sensing system, the triboelectric or piezoelectric sensor material that I am working on. So the thing is that integration of chemistry, integration of electronics to get the good sensor is very important. Okay, so now again, this is the optical sensor, and those who are from this chemistry background, you know this in the UV visible spectrophotometer, there is one source and there is another detector. In between you have the sample. So whenever there is an intensity change, We will be getting the absorbance value, transmittance value. So here you have a reference sample, as you can see here, this line, and this line you have a sensor where you have the analyte. Obviously, whenever this light will come, there will be two difference in that absorbance or the transmittance of the system, and you will be getting the optical signal out of this kind of sensor. So this is one optical sensor. Okay. So now I'll be coming to that part. Why do we need sensor in healthcare? So what we have discussed till now? We have discussed the fundamental sensor, transducer and actuator. After that we have discussed different operation principle of different sensor. We learned about the electrochemical sensor, chemiresistive sensor, optical sensor, triboelectric sensor, piezoelectric sensor. Now we'll be discussing more on that healthcare thing, and why do you need this sensor in the healthcare? As you can see here, if you have any problem in the body system, somebody has to come our home, they have to collect this sample, or you will have to visit to the pathology. So this is also a tedious process, as well as it is also whenever you have a sensor and you can monitor all the time your body system, then it is a time saving, and this continuous monitoring is also possible. So you can avoid this process, and now you can see how many different kind of signals you can get. We can get the pressure, motion, vibration of the body system, and in the physical signals, as I told you, thermal signals. Always it is important to monitor fever, whether you have fever or not. And electrophysical system, we can get this cardiac activity or muscle movement. We can get, and then obviously the remote medical service, self-diagnosis, it can be done with the healthcare different sensors. So all these sensors, again, these are working on some principle. For medical purpose or biomedical purpose, whatever the sensors we are using, we can classify in two types. One is the non-wearable and another is the wearable sensor. Non-wearable sensor means are typically used in medical facilities or home devices. They are not worn on the body but are essential for diagnosing and the monitoring the various health conditions. So if you take this scope, we are not monitoring always, but we can monitor the. I am giving you the example as non-wearable devices. It is the same thing, same pulse rate whenever you are monitoring by using this device, smartwatch, is called the wearable devices. And nowadays, people are more interested, or research is ongoing on that wearable devices. So whatever the device is, you need a sensor, you need a receptor, and you need a transducer system. Fine? So as I told you, now we need to think what is the measurable parameter. What is the measurable parameter that you need to understand? Whether you are measuring the temperature of the body, pressure, or you need to check some kind of body fluid from the body fluid. What are the different body fluids? And it is very important when you are measuring the physical or chemical analyte. Physical analyte measurement is little bit easier. It will always give you the same signal. But the chemical environment, you need to optimize the system. Even if you bring one sensor from the market, it will not work in your IoT system. You will have to optimize that system into your system. So it is like this, your nose you have taken from somewhere, some person, and if it is replaced, then it needs some kind of optimization in the body system. Until it is optimized, it will not work. Physical parameter you can, chemical parameter you cannot. Right? So what are the different body fluids? What we can monitor apart from the blood? Apart from the blood, there are different body fluids, and both fluid and lymphatic fluid and saliva, urine, sweat. Very good. Tears, isn't it? We can monitor mucus. All these are liquid phase. Tell me some gases. Breath. A new diagnostic way, that is the breath analysis. You can dream. You will be entering into the some system like ATM machine system, and you will be giving your breath, and that breath analysis will give you the idea whether you have COPD or whether you have this diabetes or you have some disease on the kidney. Breath analysis is now this emerging tool to analyze your body parameters. Okay. So now why it is important? Because whatever the blood you have to collect, that is an invasive system. And now whenever we are taking this breath, sweat, tear, these are the non-invasive systems. This analyte. What is invasive analyte? Non-invasive analyte. Invasive process means it will give you pain. You will have to take out the sample from your body system. So if you are taking this blood from your body system, it is an invasive. It is giving you pain. Non-invasive system. This is this is the breath analysis. This is the non-invasive breath analysis. And if you can do so, suppose you can monitor the diabetes. If you have diabetes, or probably you may have kind of experience, whenever there is a diabetes, every time you have to take the this blood and then ACU check, and all the time you monitor this thing, and it is an invasive process. Every day you have to collect the blood, and then you will be monitoring this blood glucose. But if you have this breath analyzer, in the breath there is more ketone or acetone in the breath of diabetic people. So if you compare these healthy people and then diabetic people, by monitoring the this acetone or the ketone, because it forms sensing system, and this is sensing system, and this is the invasive and non-invasive system. So I'll be now giving you few examples what people have used. So that is, these are not my work. I am just giving you some work which is published in the different good journals, like it is published in the SCS Nano, and it is a FET based this sensor, and in that transistor based system they have used what they have used. This is a glucose sensor, and artificial eye was fabricated to examine the glucose detection from the tear. So this is one eye, and this is developed, and then it can detect the tear. So if you see this device, the device is prepared from this indium oxide based material, and this indium oxide based material is coated on that electrode, and then from that they are getting the signal of glucose. So whenever there is a glucose, if the proton generated from the glucose in presence of glucose oxidase, one enzyme is also given, and then glucose oxidase, it is oxidizing the glucose, and then the change in the electron, this transistor system, you can get it from this signal. So what is the material here? Here it is, the material is the indium oxide, and what is the analyte here? There is the tear, and in the tear there is glucose, and what we are monitoring? We are monitoring this transistor signal, and that is the transduction system. And so we have the receptor here, iron-203, or analyte is the tear, and then transduction system is the transistor this transduction system. We can get the signal out of here. So this that was the analyte, was the tear. Now as you can see here, this is the again another referred article. This is not my work. Here the blood glucose is monitored from the sweat. Blood glucose is monitored from the sweat, and artificial sweat is created, and from that this is a biosensor, and in the biosensor means this is electrochemical sensor, and this electrochemical sensor can also detect this sweat. So in the electrochemical sensor system, as I told you, you should have 3 electrode system. Similar thing they have prepared, and they have measured the glucose in the sweat. So if you are planning to start some kind of work, or if you are working on that system, sometimes you may have the mind, sir, where from we will be getting that analyte, tear or sweat. Okay, and who will certify that? Okay, so here as you can see here, this is artificial sweat has been created. So what is the recommendation? That thing you can follow that thing, and then you can test your analytes. Okay, and then you can go to that actual work in situ treatment. For that you need a recommendation from a physician. Okay, you can get that. Now again, it is a system, again electrochemical sensor. It is determine the prostate cancer. For the male, it is now tremendously very this is very important now. This is to monitor this prostate cancer, and then this electrochemical sensor is now being used to monitor this prostate cancer. And in this prostate cancer, whenever you have this prostate cancer, you have this prostate specific antigen. So this is the analyte here, PSA, and we will have to detect that PSA using some material. So material, as you can see here, this is nothing but a 3 electrode system. The same 3 electrode system we can use, or we can prepare, and our different can be here different. So as you can see here it is use the graphene kind of thing, and they have prepared this material. So working electrode is ready, reference electrode is ready, counter electrode is ready. Then you can start with the electrochemical measurement, and after getting this electrochemical measurement, when it is done in the laboratory, you can integrate with the electronic system, and you can get the information of about the PSA, that is the this prostate specific antigen. Now this is this information, it is important for you. Prostate specific antigen, what is the analyte, what is the chemical composition of that analyte, and what could be suitable as a receptor to that analyte. That very intellectual idea is required from a bio person or a chemistry person, and which will give you the electrochemical signal or electrical signal. Later on you can work on it. So what is the this is the PSA, that is the antigen, and then so as you can see here, this is the breath. Again I told you what are the different kind of body fluids, and here important body fluid, as you can see here, 34% nowadays it is the breath samples are being treated, and whenever we are taking the breath sample, there are thousands of VOCs in the breath. So even if you have this do the experiment using the pure acetone, because pure acetone you do not have this moisture there, but in the breath we have always the moisture along with the other these VOCs. So you will have to create an environment where you can test the VOCs along with the other, along with the target acetone. So in that way you can also prepare the different sample. So for the detection of this breath sample for this electrochemical sensor system, but whenever this is the gas detection or volatile organic detection, then there is specific sensors, and one type of this sensor is called this chemi-resistive SMO, that is this semiconducting metal oxide based chemi-resistive sensor. This is one sensor which is cost effective, but other way you can also detect the VOCs or gases like PID, photoionization detector. This is PID and then FID, flame ionization detector, you can use to detect the VOCs or these gases. But here the MOS, that is the SMO gas sensor, you can use, and these SMO gas sensors are called the chemi-resistive sensor. Okay, so what I have discussed till now: sensor, transducer, and then actuator. After that we discuss many sensor principle, electrochemical, optical, and then triboelectric, and then because what I am recalling the things just to let you connect with the my talk, because something, my intention is that you will be taking something away from this lecture. So that's why we discussed that operation principle. Then we started this some healthcare sensors, and where we have given the different kind of analyte, different kind of body fluid like sweat, tear, and then also the PSA, prostate specific antigen. I have given you the example. So after this we will be talking more about the breath analysis or the VOC analysis. And now in my lab we are working on that 4 different kind of sensor. That is the chemi-resistive sensor, electrochemical sensor, plasmonic sensor, and then colorimetric sensor. currently we do not have this facility in my lab. I did it in USA, but this plasmonic sensing measurement we do not have. But these three things we have chemical-resistive sensor, electrochemical sensor, and then biometric sensing measurement facilities. So what is you can target different kind of analyte. The main thing, how you are preparing the sensor. If you have a chemical-resistive sensor, it will change the resistance of this sensor. An electrochemical sensor will give you the particular threshold voltage where the oxidation or reduction takes place. Sensor, you will be getting the change in the color or change in the wavelength or change the intensity of the this output and then input this light. So in that way you can detect different kind of sensor. Mostly I will be discussing now in the chemi-resistive sensor. Okay. Since there is no less time, we will not discuss electrochemical sensor or biometric sensor. We will be discussing more of the chemi-resistive sensor. And the target is that to detect the VOCs or that your gases. Okay, any gas or VOC can be detected using the chemi-resistive sensor. And this type of chemi-resistive sensors, you can say this is directly used for that. Sometimes for the biomedical applications like acetone, as you can see, formaldehyde, also these are used for the phase analysis. And but if you are working on a chemistry laboratory, always if you have to take care of your health, and then volatile organics are creating a lot of negative impact in the body system. So in that indirectly, if you want to relate this topic with the healthcare, it is also related to that healthcare. You are taking care of your health by monitoring the VOCs. So there are different kind of sensor to measurement also in the gases, electrochemical, capacitive, optical, but here it is the chemi-resistive. And mostly what are used in the chemi-resistive sensor, this is the metal oxide. Metal oxide or semiconductor oxides or some polymer like this polyaniline, these are used, which are conducting polymer, these are used for the sensing of gases. So these metal oxides or polymer, these are the receptor. These are the receptor, and when they will react with the some VOCs or volatile organics, they will create a signal, and then that signal will be transduced to the this control system. So now I am discussing on the chemi-resistive sensor. Okay. So what is the principle here? Those who are from this chemistry background or those who wants to know the interaction more, you can see this is the material, and when this is kept at high temperature, that oxygen molecule will come. When the oxygen molecule will come, the resistance will increase. At high temperature, so this will be the sensor, and then whenever reducing gases or any volatile organism will come, you will be finding there is a change in the resistance of the sample, and ultimately when again the oxygen will absorb on the surface, you will be getting a change in the signal. So ultimately this is an animated figure what happens for a chemi-resistive sensor, but ultimately you will be getting this kind of transient, it is called the transient resistance transient. So the change of resistance with time, this kind of sensing signal will be getting from a chemi-resistive sensor. So now to measure this chemi-resistive sensing performance of any material, what you need a system where you will be putting your sample, and then you will be injecting the analyte, and then you will be measuring the signal change. How can you develop that system? So there are two kind of system here. One is called the static system, means there is no flow, you are just injecting the gases and you are measuring the signal. And this is the dynamic flow, so you have an inlet and outlet, and from that you can measure the sensing signal. Okay, so this kind of, I am lucky enough that this kind of setup I built from my PhD days, and I moved from that organic chemistry to that sensing, and then I could learn the things. So for that you need, you should have a wheel to learn the things. So as you can see, this is the sample and this is the reactor. You have a gas in and gas out, and these are the transduction system that is connected to that Mithle electrometer. Okay, so similar setup, I do not know whether Rahul sir has started or not, but similar setup Rahul sir has also worked on. And then this is the static flow gas sensing setup, and that is also available now in ATPU as well. So you can inject the gas and you can measure the sensing. So what are the different properties of the material? How many of you are from chemistry background? Electronics? Most of the students from what background? Biology. Huh? Biology, okay, fine. So as you can see, if you wish to get the interaction from the material or analyte, so there are different properties of the material, that is the receptor function, transcription function, and affinity factor. So receptor function means the surface area, porous nature, phase purity, grain size. So these are the different property of the materials, and you can monitor or you can prepare your materials by maintaining these properties. And when you are preparing this material, after that the second thing is the interaction. And these are the again some figures. As you can see, the SCM images related to the mostly the chemistry or material scientist people, and these are the different morphology of the metal oxides and with the different surface area, you can see. So we have prepared different materials, but that mostly it is not interested to you. So I am not going to the detail of these things. So now again, if you prepare this material in different morphology, we'll be getting the more sensing. Means we are working on the surface area to volume ratio of the material. So now we are getting the different morphology, and then if you can prepare the different morphology using a simple methodology, that is again related to some chemistry part, and you can prepare the material. What I am doing now, I am just preparing the material for a sensor. If you are from any background, forget it, I am doing nothing but preparing a material for sensing. So these are the different kind of materials we have prepared in the laboratory, and sometimes we have modified them using some metal or the noble metal to enhance the performance. So these are the techniques. These are the techniques to improve the sensing capacity. So again, background, it does not matter always. You know what is there in a this airbag. My open question is, it is not related to this. What is there in a airbag? An airbag is a life-saving technology. Whenever you are in a vehicle, it's airbag, life-saving technology. Who has contributed it? Who has prepared it? Chemistry, physics, mechanical, electrical, electronics, computer, biologists. Who has prepared it? But it is life-saving. Everybody is getting benefit from this. Who has prepared this airbag? And what is there inside the airbag? Whenever you are driving a vehicle, in your steering there is a airbag. Is it full of air? What it is? So this type of questions the young students they should have in the mind. What is there in the airbag? Very good. So what is that chemical compound, you know? That is sodium azide is a solid. Okay, sodium azide, nowadays different other materials are being used. What I am saying, so what is the importance of sensor, you will be finding here also. That is a material that is called the sodium azide, and sodium azide, when it explodes, it will give you the nitrogen. Okay, so whenever you are working, when there is thrust, and a significant amount of thrust is there, not in the all thrust it will open, when there is a significant thrust, so what will happen? That will create a signal. That thrust, that is a sensor. Okay, and that thrust is giving you instruction that you just fulfill that circuit, and then when there is a fulfill of circuit is closed, then it will create a spark, and that spark will create a explosion of the sodium azide, and ultimately you will be getting huge amount of this nitrogen in a full of bag. Okay, so the thing is that nobody is bothered about what is your discipline. You should have mind in this is the problem solving attitude. The problem solving attitude. So you'll have to create that thing. If you wish to develop a material for sensing, you can develop that sensing or sensor material. Your target is maybe you know better the analyte because you are from the bio background. But the sensor, when you need to prepare, you'll have to take the help from the in chemistry people, you need to take the help from the physics people. To integrate the sensor, you need the help from the electronic people. So everything is integrated. Okay, nothing is discrete. Your mindset should be integrated like that. Okay, so so these are the material. I am not discussing this thing because those who are interested on the materials and the sensor, you can find there are different materials we are preparing, and also we are targeting the acetone, which is one a biomarker for the diabetes in our study. But it is very interesting to give you some thoughts, sir. If I have to leave, then tell me. Just 5 minutes. Okay. So now it is very interesting. Okay, how these gases interact on the sensing surface. If you have a gas phase analyte, is it not like that gases are coming on the sensor and it is giving you the signal? So as you can see, if you have a cricket ball in hand, it will not this just absorb on the surface. So all the gases which are coming on the surface, these are not absorbed. So something is absorbed and something is dissolved. It will not absorb on the surface until it loses its energy. If you have to sit here, you have to lose the energy, and that very things we can also show you through the Lennard-Jones potential diagram, and there can be different trajectory of this Lennard-Jones potential diagram. What I am showing, how the gas molecules coming and sitting on the sensing surface and giving you the signal. So there are different trajectory. Suppose there is an interaction, and in this interaction there is no loss of energy. If there is no loss of energy, it cannot sit. So whenever you are seated on this place, you have lost your energy. Now you are stable. So that's why you are there. So this is inelastic trajectory. So it is getting more energy after the interaction. Striking trajectory means it is very important trajectory which is giving you the sensing signal. What does it mean? It is showing you, see, it is losing enough energy, it is coming to the chemical option well. By losing energy, then it is coming on the surface of the sensor, and then it is giving you the this signal. And this is the PG absorption well. So you need to give it more energy to come to that chemical option well. So this is why I am showing so. This is the different kinetics of the interaction between the analyte and the sensing system. So now you may have a different kind of analyte. Sometimes your analyte, this is oriented and this will sit on that sensing surface like this. So it will come and directly sit on that surface. But if it is not oriented, then first it will orient it and then it will sit on the adsorption surface. Remember, this green color is your analyte and this brown color is nothing but your sensor, that is the receptor. Now suppose you have a heteroatom and it is oriented, and so whenever it will come to the surface, it will come and then sit on the surface and then it will give you the signal. But it is not oriented, no, I will not sit here. So those who are interested to explore the sensor science, so you can do it. But this chemical sensor again, it can be used for different other purposes, which is very. So how to improve the selectivity of the sensor? Isomeric compounds. What does it mean? Again, these are some chemistry. So this is the setup. Isomeric system. Do you know what is isomer? Anyone? Isomer means 1 propanol and 2 propanol. Those are having the same masses, we call it isomer. When they have the same masses, many properties are also same. Sensors cannot detect it. Okay, so there are these kind of sensors can be tailored to monitor the different kind of gases as well. So as you can see here, this is the different sensing system in presence of methanol, ethanol, propanol, butanol. So as you can see, for different these gases, it can give you the different sensing signal. But whenever it is a isomer, means the masses are same, but you can also detect these things using a sensor like 2 propanol and 1 propanol. The masses are same, but it can be tailored to give you this kind of sensing signal. So this is the sensing signal. If there is a temperature, you will be getting the different kind of performance in the sensor, and there is an optimized operating temperature for this sensor. If you are doing research on the sensor, and you will have to explore the optimum temperature, then it is Again, you see, this is the repeatability of the sensor. Repeatability sensor. So in each concentration, and if you just turn on the sensor, then all the time we are getting the same signal. Remember, it is prepared in the laboratory. It is not commercialized sensor. Still, we are getting the all the this repeatable results here. So this is whether this is a concentration variation or temperature variation, we are getting the repeatable results. So it is again, it is not very interesting to you how this interacts and how this happens, because again you need to understand the science behind it. When two gases are interacting on the surface, that is the heterocatalysis. One this analyte is coming, then again another analyte is coming, then they are this interacting and they are forming the product. So with this you can also this you can also modulate the tangents and you can get the different sensing parameters out of it. So these are the some things you can get that one propanol and two propanol, these are having the different activation energy, and this is the general activation energy curve which is open use. Now again the MS study. This workshop is also related to that machine learning and then artificial intelligence. So whenever you have a different analyte, how these machine learning algorithms can be used to identify. So as you can see here, we have also taken this data and then we have performed the MS study, and just to discriminate one propanol and two propanol. Here you may consider these also as a discrimination. You have a different analyte in the breath sample. How to discriminate that? For that, this ML analysis of the machine learning algorithms can be used. So in the machine learning algorithms, we have a set of data. So we have a set of data. Total data set we have taken, the 1600 data set we have taken, and then we have trained the 1280 data set we have trained, and we have tested the 320 data set, and all these data sets will be getting the current value of this this sensor. So the thing is that ML study can also selectively detect the different analytes. So again the repeatability and the different sensor. So this is the repeatable sensing system. As you can see here, one propanol and two propanol. These are one propanol and two propanol. These are mixed into 0 to 100. Then 25, 75. We have mixed now. We have created this more complicated problem. We have mixed the volatile organite, and now what will be the signal? So this is the sensing signal. Here also we have got the different sensing signal. And if you again take this is known set of data and this is unknown set of data. So as you can see, the unknown set of data is overlapping with the known set of data, and like the Lambert-Weir law, you can also comment on the analyte concentration in the mixture. Okay. So we did again the ML analysis to identify what is the proportion of one propanol and two propanol in a mixture. So this is a binary mixture. What I am doing nothing again. I have just tried to understand the interaction of gases with the sensing surface, and when the interactions are similar, how to discriminate. The possibilities lies with the kinetics, the possibilities lies with the machine learning, and that very methodology probably you may not learn till today, but in future you may learn this machine learning algorithms or statistical algorithms or kinetic algorithm to discriminate different vapors. Problems is different in your breath system. It is not easy to detect the ammonia or the this acetone or any other analyte until you do the sensing measurement. You get the sensing repeatable sensing signal. So as you can see here, these are the repeatable sensing signal we have obtained for the mixture of one propanol and two propanol from the setup whatever we have developed in the lab, from the sensor whatever we have prepared in the lab, and then from the data wherever which are collected from our lab. So the thing is that again, starting from the development of the sensing setup to development of the sensor, taking the signal, and also the data acquisition system, that is also we are not using the Hitley, but we have prepared our own system for the data acquisition. If you are interested on the sensing of different materials, not only through the chemiresistive sensor, But for the electrochemical or this optical sensor, you may anytime you can visit the permission from Rahul sir or ma'am, and then I'll be happy to show you the different this work which is currently going on the sensor. So as you can see, this type of prototype sensor also we have developed in the lab, and this is the material we have prepared, and then included temperature, and this is a sensor whatever we have developed, this is the work I carried out in the USA. So this is a lithography based sensor system. Probably you may not have that kind of exposure now. That is a nano fab. So how to prepare the nano materials or nano sensors? So that also we can do. And this sensor, out of this sensor you can get this sensor signal. So summary is that in this way, as sensor technology continues to evolve, we can expect even more innovative solutions to emerge, revolutionizing the future of healthcare. So in the healthcare, so I have given you different example of this sensor system, and these sensor systems can be used to detect the physical parameters like temperature, pressure, to detect the liquid body fluid, like whatever you have this blood or sweat or tear, you can use this kind of system. Even the body fluid is gas like breath, you can prepare also your system using the metal oxide system. So now with this knowledge about the sensor and transducer and actuator, you can at least plan your this target or analyte, and then you can tune your sensor, or you can take some initiative with the support from your sir or ma'am to do some work on the sensor in future. The target analyte will be fixing, because you know much better than us regarding the biological activity of some material, because you are a biologist. Okay, so this is the lab. We are carrying out research PDPU. So this is the gas sensing setup, which is for the measurement of metal oxide based sensor, that is the gas sensor, and this is the electrochemical sensor. This is supported by the DST ACRB, and recently one project is also supported by the World Society of Chemistry and the Gujarat Environment Management Institute. This is my group, and anytime if you wish to do any work on that development of sensor, then you are always welcome. Obviously some part of work we could not perform because of our expertise it is not there in that field. So like river strategy carried out with our collaborator Dr. Amitabh Chaudhary in the PDPU. But starting from the sensor development, and then setup, material preparation, characterization, everything is done. Fine. So thank you for listening at least. I do not know how much you have understood, but thank you. So if you have any questions, yes.
So as you said, we can make the sensors nano and small in size, and we make them small in size that they can fit into the xenobots, which can be used for sensor therapy or any other therapy.
What is the dimension?
So the dimension of the xenobot is like 1 millimeter, 0.04 inches also.
Obviously you can do. Millimeter scale, obviously you can do. Even micron, you don't have problem. But the facilities to prepare that in the micron scale, I do not know whether photolithography is here or not. If photolithography is there, then you can do. If photolithography fabrication is not there, then in the millimeter scale you can do in the lab. You can see the normal lab. You can prepare this millimeter scale even in my lab. But in the micron size lab, you need this photolithography technique. I do not know, sir, do you have here photolithography? But sir has worked on that photolithography. So this, and then if you even go to the lower dimension, then you can go for this electron beam lithography, EBL.
All are students from IIT. They are not from IIT.
Okay, outside will find no problem. But yes, whatever, again I told you, I am telling you that what is your discipline, that is not important. Your attitude to solve the problem is important. I always tell the students that your attitude should be problem solving attitude, and that is not my this I am telling you, this is government of India is telling. Okay. Attitude should be problem solving. Problem, they don't have any discipline. If there is any problem, is there any discipline? So I am from this discipline, I am this problem. No, problem is problem. Yeah, obviously sometimes it is purely mechanical or purely electrical, but problem is problem. And any other question, anything you have in mind? If you have a silly question, you can ask.
So are there any libraries or tools that we can find the compounds or molecules which can be used in chemosynthesis, which are basically best to bind with a particular gas or something, which analyte it can bind efficiently?
So that's why I told you, when it is a chemical sensor, even if you have a library of molecules, you'll have to optimize the system in the lab, because the system environment is so complicated. Until you monitor this, create an environment, then your sensor will not work. Suppose my nose is working in this environment, but if you have a mango, I can detect tobacco. But if you keep me in some other room which is very crowded, and maybe the room is even bigger, then I may not get that smell, isn't it? So it depends where it is working. Mango, depending on the environment, it may not. Sensors are first trained from our childhood. That's why these sensors are now working. Okay. We can sense, we can hear, because from the childhood we have this is trained. Our nose is trained from our childhood that this is mango. Our eyes are trained. This is black, this is blue, this is green. Until it is trained, you cannot act. Training of the sensor is important. Right?
Any other questions? Any questions?
Thank you for the insightful session, sir. As we conclude this insightful session, let us take a moment to express our gratitude to our distinguished speaker, Dr. Kalisajan Mukherjee, for their valuable time and knowledge. I would now like to request Dr. Bhovya ma'am to kindly present a token of appreciation to Dr. Kalisajan Mukherjee. Now, after 5 minutes, we will have a talk from Dr. Carlo Mascheroni. Now, that will be an online session.
Those who are yet to fill out the attendance list.
हार्दिक लाइव स्टॉप करेगा.